This video is going to be about lesson 6.5, which is on factoring special forms, and specifically we'll be looking at this difference of two squares. So with this formula and this pattern with difference of two squares, essentially when we see something, whatever it might be, variable, or maybe it's a constant, something being squared minus another something being squared, that factors into a plus b times a minus b. So this is something that we'll be using in several of these following examples. Our first example is question number 4 out of the textbook, and this one says we have negative p squared plus q squared. This is going to end up using the difference of two squares. It just doesn't look quite like the difference yet, because right now it has a sum, the addition sign, in between our two terms. This can be rewrote, though, so that it says q squared minus p squared, and now we have our difference of squares, where q is going to be our a value and p is our b value. So this is going to factor into q plus p times q minus p, and that's as far as we can go with this question. Number 8 is the next example out of the textbook again, x squared y squared minus 25. This is another one where it's not quite row, it is a difference, but we can't easily see what our a and b values are. So we can rewrite this so that it looks like we have some quantity squared minus another quantity squared. X squared y squared is the same as xy to the second power. Because if we use our rules for exponents, this would turn into x squared y squared. Minus 25 wrote as something squared would be 5 squared. So now we can see, okay, this is our a value and this is our b value, and using our formula for difference of two squares, this is just going to be xy plus 5, so a plus b, times xy minus 5, a minus b. And that's as far as we can go with this question with factoring. The next example, again, is one where it's disguised, but it is going to end up being a difference of squares question. And a lot of times to be able to tell this, it's because you only have two terms. So it's not a trinomial to try to factor. And we do have this exponent here where we see that something is being squared. So to start this problem, we're going to start off by saying, okay, is there something that I can factor out of both 50 and 8? And perhaps that would leave me with something that, again, are perfect squares so that we can rewrite it as a difference of squares. Both 50 and 8 can be divided by 2. So we're going to factor out a 2, and what I'm left with is going to be 25 minus and then 4y squared. So now we have something that is going to be more helpful when we go to do this difference of squares. The 2 is just going to hang out front. And remember, 25 we can rewrite as 5 squared. This here, this 4y squared, we can rewrite this as minus, and then we can write this as 2y squared, because this would do 2 squared, turn into 4, and then y to the second power would be the y squared. So now that we rewrote it out like that, we can hopefully see a little bit easier what our a and b values are. So a is going to be 5, b is 2y, and so this is going to be 2, because we still have the 2 out front of this whole quantity. And then it's going to be a plus b, so 5 plus 2y, times a minus b, so 5 minus 2y. And that would be it for that question. And then taking a look at our next one, number 14, we got 8a squared minus 18b squared. So with this one, again, it's very similar to the last problem where we don't necessarily see those perfect squares in order to help us factor this problem. But it's very similar to the last one where these are both divisible by 2. So if they're both divisible by 2, that's what we're going to factor out. So now we're going to have 2, and then in parentheses, this will be 4a squared minus 9b squared. So once again, we can rewrite this so that we can more easily see what our a and b values are. 4a squared, very similar to what we did up here. This is going to be 2a, that whole quantity raised to the second power, minus 9b squared. That breaks down into 3b squared. Because again, 2 squared gives me the 4, a squared would be that a squared there, 3 squared would be the 9, and then b to the second power would give me the b squared that's attached to the 9. So now, again, we can see here's our a value, here's our b value. So difference of squares says that when we factor it, it turns into a plus b times a minus b. So we're going to have 2, because again, we still have to carry that along, 2a plus 3b times 2a minus 3b. And that would be it for this question. Our next example is also going to involve that pattern that we use for difference of two squares and how to factor it. This, again, is not wrote in a way where we can easily see what the a and b values are. So we can rewrite this. Now, 81x to the fourth, that breaks down into 9x squared, and all of that is being raised to the second power. So 9 squared would be the 81, x squared squared is x to the fourth. And then 16, so a minus, and then this will be 4 squared. So our a and b values, our a value is 9x squared, and our b value is 4. So this is going to factor into, again, a plus b times a minus b. So we'll have 9x squared plus 4, and then multiplied by 9x squared minus 4. This next example, number 20 out of the book, is going to also follow that same kind of pattern, or that same mindset of we need to rewrite this as something squared. So m to the 8th, this is the same as m to the 4th squared minus, and then this is going to be the same as 4n squared squared. Again, if we double check this, 4 times 2 gives me the 8th power, so again, goes back to rules for exponents. And then 4 to the second power gives me 16, and then n squared squared is n to the 4th. So we have our a and we have our b value. So now we can rewrite this as this product, where we have m to the 4th plus 4n squared times m to the 4th minus 4n squared. And that would be it for that question. Now, these next few examples we're going to take a look at, they do follow special forms, but they're not necessarily something that you have to memorize. So we have things like basically factoring perfect square trinomials, and it's not something you have to, like I said, memorize. You can do the same patterns that we've followed before with using this X method to help organize our thoughts so that we can get this factored into its most basic form. So with this trinomial here, if you don't know the rule for this perfect square trinomial, that is okay. So we can go through and, just like before, organize our thoughts by saying, okay, what's going to multiply to 64, but then add to get to 16? And that combination is 8 times 8. So 8 times 8 gives me 64, but it also adds to 16. So this is going to factor into m plus 8 times m plus 8, and then we can simplify this more by writing as m plus 8 squared. And that would be the final answer for that question. This one here now goes a little bit further, because instead of having a 1 in front of our first term of this trinomial, we actually have a 9. So this is where we can use that AC method, which involves factoring by grouping as well. So to start off, we can again use our strategy of essentially using our X method to help organize our thoughts. We're going to do 9 times 25, so A times C. So 9 times 25 is 225. And then we're trying to figure out, okay, what's going to multiply to 225, but then also give me negative 30? Well, if they're going to have to add to get to a negative, keep in mind this means that both of these have to be negative. And both of those numbers end up being 15. So negative 15 times negative 15 is 225, but then adds to negative 30. So when we go and rewrite this so that we can do factor by grouping, these two here tell me what to break down this middle term into. So this is going to be 9h squared minus 15h, and then I'm just going to write this as plus negative 15h, just so it's a little bit easier to see that negative there. And then we have plus 25. So now we can do our factor by grouping since we have 4 terms. We'll group these first 2 terms together, group the last 2 terms together, And then we have to figure out, again, what can be factored out of each of these groups. So focusing on our first group, we have 9h squared minus 15h. So factoring out the GCF of those two, 3h, we're going to be left with 3h minus 5. Then, over on this side, again, remember our goal is to have the same exact thing left over after we factor out the GCF of these two. So we are going to want to factor out a negative 5, because then what I'm going to be left with is a positive 3h, which is perfect, and negative 5 times a minus 5, or negative 5, would give me that positive 25 there, which is, again, perfect, because now I have the same thing that can be factored out of both of these terms. So this 3h minus 5, we can rewrite that out front. But we're also left with 3h plus negative 5, which is the same as 3h minus 5. And so this ends up being 3h minus 5 squared as our final answer.